contractor also will be there. They will jointly set out the structure. So normally we will have a plan, and in which normally we will be having the wall being given over there. And what will be the start of any construction? It is the foundation. Am I correct or not? So to construct the foundation, we require to have a wider opening over there. So that part is the first one that we do is the excavation. Am I correct or not? So you can find like many good and bad is there. This is almost a comparison that we are going to do here, like good and bad. So what is good and what is bad, you should understand clearly. Normally, we will cut the structure or the soil for the foundation, and we have a tendency to store it on the top of the same soil adjacent to it. So what normally happens is immediately you do such an activity, you can see that how clumsy is that on the other side. In the back side, you can see how clumsy it is. All the soil is being excavated and kept on the top of the shore. There are 100% chances of this to get slided down. Am I correct or not? And on the other side, you can see they are cutting it in the equal depth everywhere. Equal depth everywhere. Because there is a depth of foundation. Normally it will be 45, proceeding to 60, and then again another 160 would be there. That will be the normal foundation width. Depth also would be there accordingly. So those depths and all will be clearly has to be cut like that as shown in the first figure. And the second figure you can see it is in the step format. You can see the persons are walking through the there is your cut region itself, making or facilitating them a step. Do you feel like they are going to clear that area again? No. Once they complete the excavation, they will just dump in all the there is your rubbles over there, and they will go ahead with the construction. So what normally happens is the thickness would be lesser. The foundation thickness would be lesser, which is the basics of everything. And normally what the persons would say is, sir, this is going to be closed down by the soil. There is nothing to look at it, and we will do it in the superstructure. But whatever is not seen has to be dealt in very serious manner, right? Because we are not going to see any distress over there. If any distress comes to the foundation, it is going to affect your superstructure also. Am I correct or not? Do you agree with me? Yes. Okay, fine. Now we shall go ahead. Once the excavation is over, we will do with PCC. PCC is ignored actually. Many of the construction sites, if you just go and observe, they will just stack the structure like that. They will just stack the stones. All sorts of unwanted stones will be stacked, and over which they will put some slurry. Cement, sand, slurry they will put, and they will just ram. That is not the right way. What we are supposed to do, as good as concrete, we have to make using 40 mm aggregates. 40 mm, big boulders, no? With that, we have to mix it thoroughly as we make the concrete, and the PCC has to be laid. Normally, the thickness would be of 10 mm, or 10 centimeters would be the thickness of the PCC. That has to be laid. That thickness has to be maintained. In the other case, can you ensure the thickness over there? And all sorts of aggregates are there, flaky types, large pieces are there. Have you seen that? This is from our own Kerala sites. I have taken these figures. It is not anywhere from the outside we have taken. Many of the pictures are the sites adjacent to this institute or in Ernakulam district. Okay, so you will wonder how construction practices are going very badly and disfaming the engineers or the constructors. Okay, so this is about the PCC. And coming to the next one, we will go ahead with the random rubble masonry. Why this RR is so important? Because conventional houses, we never go for 5 foundation at all, right? Do we go for 5 foundation? A G+1 structure or G+2 structure, we can manage using RR. What do you mean by RR? What do you mean by RR? Random rubble masonry, random rubble. So the aggregates or whatever boulders that we have, that is your rock pieces that we have, it should be shaped properly and arranged in a particular fashion. There is a fashion for it. how it has to be arranged. And at regular intervals, you should have something known as bone stones. What do you mean by a bone stone? Bone stone means what? A stone which covers minimum 80% of the total width of the structure. Minimum 80%. Ideally, full. But that is not practically possible. So at regular intervals, we may have to provide a stone or a big piece of stone which connects the entire structure in the width. Why that is so important? You all know that in the random total masonry, when you construct, we will be aligning our walls in between, that is at the center line. Am I correct or not? So when you keep the structure exactly at the center line, there is a tendency of this to act a load at the very vertical or very center of the structure, which may get or cause the material to shift or it will displace. In order to avoid that, you have an appropriate bonding for all the foundation. In alternate intervals, we will be having, or regular intervals, we will be having these bone stones. Now you can see here, one bone stone is from this side, right hand side, bottommost. And in the next layer, the bone stone will be in the periphery of the other side. So it has a connection in between, right? Yes or no? So that sort of arrangements is necessary, which is being ignored. And we are supposed to provide weak holes. What do you mean by this weak hole? What do you mean by this weak hole? It's a foundation, right? There will be any time ingress of moisture inside your structure. So that moisture is not, especially in the cases of retaining walls and all. Soil will be there on one side and the other side it will be free. So when the soil has ingress of moisture, this moisture is not going to stay over there. What it does, it will go and hit this wall. Am I correct or not? And when it hits the wall, it should not exert a pressure over there to the wall. The moisture and the pressure would indulge. So for that, what we normally does, we provide a weep hole at regular intervals, inclined, so that the water gets drained in. It will not create any pressure onto the retaining wall or the structural member. Okay, is that concept clear for you? Yes or no? Okay. Now you can see, normally the stone masonry, it's the place where all sorts of mischiefs will happen. They will not be regularly packed, dressed properly. Thus, all the stones that we are getting, RR that we are getting, it has to be dressed, knocked. Why that knocking is so important, you know? All the stones or the boulders that we get to the side will not be perfect always. It will, you know how it is being extracted from a quarry? You know how it is being extracted from a quarry? They will be bursting it, right? By bombardments. They will be using some, detonators, and they will burst it, which causes infinite number of fracture between the structure, between the rocks. So even though we feel like this rock is going to be very perfect, 100% perfect, but it will not be perfect. We will be having intermediate flaws inside it. So how can you get to know that this does not have a flaws inside? Have you ever noticed those who are making a sculpture out of rocks? You know sculpture, right? Bimbangala. When you make a sculpture out of rocks, they will knock the structure using hammers. They will listen to the sound of that rocks. If there is any flaws in between, it sounds different. Now for them, it is so important because once they make the entire sculpture and once they work with the face, if the neck breaks, entire efforts of making the structure is lost, right? Yes or no? So that is why they knock and see whether the sound is good or not. So like that, you would have noticed, knowingly or unknowingly, a good mason who is working with RR will knock the structure using hammer so that they will get to know that the rock is good or not. And you can see here, this poor person who is doing work over there, he is just aligning the rocks. He is not shaping it. Now, what ultimately happens to such a structure? You will not have bone stones. Regular shape of that foundation would not be there. All this is going to affect, including the aesthetics of the structure. including the aesthetics of the structure. Am I correct or not? Structure. So that is very, very important. So foundation is an important structure. We cannot ignore it. We have to be very careful about it. Now, once we do that, then comes our plinth beam, right? What is this plinth beam? Why is it so important? In olden days, this plinth beam was totally ignored. Now, slowly, everybody is going for this plinth beam. Plinth beam is acting as two important activity or two important requirements of a construction. First thing, a firm base for the superstructure to start. Okay, a firm base for the superstructure. And second important factor is that S5, you have learned something known as dam proof course. Have you learned about it? This dam proof course is nothing but it is a plinth beam acts as the dam proof course actually. It will avoid the ingress of moisture to the superstructure. Normally the superstructure will be built using bricks. The bricks have a higher affinity to absorb water. So it should not absorb the water. There should be a curtailment of the moisture. This plinth beam acts as dam proof course also. Is that concept clear? Yes or no? So now, how this is to be constructed, that is also very important. Normally, the thickness will not be that sufficient. They will just put a ring. No, you have to provide a caging like this itself. A full stirrup has to be provided and it has to be regularly done as it's a concrete structure. It is going to behave in two different ways. One way, it is going to have a firm ground, and another important, second A or B over there is, it is going to be a firm base against seismic activities also. If there is a plinth beam over there, the effect of the seismic activity passing on to the superstructure will be lesser. So there is a binding type. If you take a bunch of something like a broomstick, you provide a knot over there that acts as a firm surface or firm attachment. Am I correct or not? Similar to that, for the entire structure, this plinth beam is going to be it has a different saying also. They will say something like, somebody in colloquially they will say like belt. Am I correct or not? Belt to arca. Colloquially they say so. That is also there. Coming to the next one, let us see. We will see some errors in the construction. You can see that continuous vertical joints, it has to be avoided. You can see the continuous vertical joint over there, right? Red arrow, continuous vertical joint, it has to be avoided. Why? And that too in the corner. Am I correct or not? That too in the corner, wherein the loads will be adversely being or going to get transferred. In that position itself, if you have a continuous vertical joint, it is going to break over there. A structure can break. And another one more thing, here again there is a mistake. You can see here, gap between masonry and the column. Normally, there will be a carporch or a structure, a long structure will be there in which we should have a column over there. Now the column will be constructed and then the RR will be done later. So what happens is this gap would be there in that case. Gap, if you see the gap, it would be good because you can do something. But normally what the persons will do is, those who are doing the RR towards the end, they will fill in just the mortar inside. So what happens is, that is the weakest joint thereof. Okay, so anything happens to the structure, this area is going to get cracks. And that crack is not going to get limited over that region alone, it will get transferred to the superstructure also. You will find n number of cracks in the superstructure. Sadhana load വരുമ്പോൾ മോളിൽ നിന്ന് താഴേക്കായിരിക്കും. ഇത് ചിലപ്പോൾ ഇവിടുന്നേ തുടങ്ങും, താഴെ നിന്നേ തുടങ്ങും. മനസ്സിലായി? So cracks ഉണ്ടാവും. It's going to happen. Coming to the next one, then comes the brick masonries. Now, bricks, you all know it is a inevitable part as far as Kerala is concerned. Many of the places, slowly this is getting replaced with some other types. There is concrete blocks, concrete bricks, etc. Am I correct or not? But still, in many places, we have this, especially in the Ram region, we normally go for this brick masonries. Now, bricks has to be properly seasoned or it has to be wetted properly. Normally, it is not been done. You should have a sump and then soak it before you construct it. Okay, there are several tests to be done. Locally available tests. You need not have a laboratory also. You can do some small tests to find the integrity of your bricks. Okay, on the quality of your bricks. Now, once done, we will go ahead with masonry part. Either over soak. So brick masonry, when you do bricks which is over soak, what normally happens is water oozes out from it. If you try to do plastering also, you cannot do it because it is having profound amount of water. And if that is the case, they will not even water it. You can see such an old person would be there in the side who will be always pouring water like this. Do you imagine or can you just imagine what happens to the central brick over there? Will it get soft? Will it get soft properly? If not, what is going to happen? If it is not going soft properly or wetted properly, what is going to happen to this brick and subsequent brick masonry? Any idea? Any idea? I'll just show you an example here. Can you go ahead with the brick masonry? I'll just show you 2-3 examples. Then you will let you know. Now, this is the next step wherein you can find these type of labas everywhere, right? They will just mix and keep materials. This is for brick masonry. You can see all our pebbles over there, big pebbles over there. Pebbles ഇവിടേക്ക് ഈ കാണുന്ന സാധനമില്ലേ ഈ കാണുന്നത് ഈ കാണുന്നൊക്കെ കല്ലുകളാണ് salt pebbles. So what is going to happen when you plaster it? That is going to weaken you, or when you do the masonry, that is going to affect you. That pebbles has to be removed. You can see that there is, for everything there is something known as a proportion, right? Yes or no? So what is the proportion we normally follow? 1:5 or 1:4 for brick masonry, right? 1:4. Like that, there is some proportion. Have they followed any proportion over there? They are just spread out on the big lot of sand or the fine aggregate. They have just spread it out, and 1 foot cement body is being emptied out there. What is the proportion that they are going to follow? Is there any proportion? No proportion. Is it a good practice or a bad practice? This is what we are going to see. You are going to see when you go to the site. These type of practices is very common, very common. Okay, and they will not be. And you can see that no sheets are provided at the bottom. You have to provide a big sheet, and then only you do all this practice. Else, what is going to happen? When you pour water, what is going to happen? I'll just show you one figure for that. Yeah. You can see that in this place, in these 4 figures, you will never find a pan. You will never find a pan. You know what is a pan, right? Mortar pan, chatti, you know it. We normally mix the materials, put it in the pan, and then the masons will take it and put it over the bricks. Am I correct or not? After stacking it. Here you will find no pan. How they are constructing, the person who is mixing will take it in the shovel and they will just put it on top of the brick mason. So you will have additional thickness of your mortar thickness would be more. The mortar thickness should be between 2. It is just 1 centimeter. Just 1 centimeter. You are not going to get any more payment if you put 3 centimeters out. Am I clear with you? Yes or no? 3 centimeter you put payment. You have put only 1 centimeter. So that's how we manage, right? What is the difference between a standard brick and a normal brick? Standard brick and normal brick size 19 by 9 by 9. The other one is 20 by 10 by 10. Am I correct or not? What is that 1 centimeter difference in all? Is the mortar thickness on either side. Half of mortar thickness for a beam on either side. Am I correct or wrong? So, what is the maximum limit of thickness that we are supposed to follow? 1 centimeter. Between two beams, 1 centimeter. Now you can see the thickness would be more anyway because they are not usually or properly using it. Another one more thing you can observe, they are mixing it and they have poured water for the full load. Full load, they have poured the full water. So what happens? As they pour water, you can see the person who is, you can see that person who is standing nearby that you will find white patches. What is that white patches? What is that white patches? Cement is going out. Cement particles are moving out. So the proportion again gets changed. Am I correct or not? Again the proportion is getting changed, altered. Water will move in all the directions, and then you can observe that once for any cement, when you pour water, there is something known as initial settling time and final settling time. You don't know that? Yes or no? Right? You have a final settling time, initial settling. What is the initial settling time of cement? Should not be less than 30 minutes. And final settling time should not be more than 600 minutes or 10 hours. Am I correct or not? So that's how it should be. Now they are going to pour the material, pour the water for the full load, and they keep that for the room. So initial settling time is over. So that again affects the quality of construction. You can see that full they have mixed. The third figure you can see full they have mixed left aside, and again they are adding water. Am I correct or not? And directly putting onto the masonry. Directly putting onto the masonry. There is no pan at all on this side. The concept you feel. So these type of ill practices are there in the sites, and you can see raking the joint should be done. Why this raking should be raking the joints in the area? Why that is important, you know? Why that is important? Because you are going to have a plaster on top of it, right? Am I correct or not? Plaster is normally measured square meter. Square meter. So thickness does not have an importance over there. How much less you can make, that will be better. Clear with you? So, for adhering such a lesser thickness, we require some vacant gaps over there. That's what is raking. Raking is done only for that. And what you can see is, once you broom it and rake it, some of the cases you will find like this. Now, what is the thickness of this between the two bricks? Can you imagine what was the thickness of the mortar? More than 3 centimeters, right? More than 3 centimeters gap is there between. And also you can find like this corner brick is almost just like a cantilever. Correct or not? How it happened, you know? After this, after making all this brick masonry, two things happens. The brick was not soft. So what happens? As soon as you place the mortar over there, whatever water that is present in the bricks will be absorbed. In the mortar will be absorbed by the bricks. So mortar gets weakened. And after that, they started carrying all sorts of reinforcements to the top floor, to the steps. So while you take the reinforcements, it normally touches everywhere, right? Yes or no? As it touches, you can find like this area, the mortar has lost because it has not attained its strength. Okay, so the entire material is also getting lost over there. You can see that the corner represents something like cantilever. These type of defective joints we will observe everywhere. And once you do it, we will do the plastering. You can expose. Yeah, you can see here, if it is a wire cut bricks or class A brick, you can go ahead with no plastering at all. So it's in all sorts of low-cost housing concepts, we will avoid this plastering process. Because that other one itself will give a very good aesthetic appearance. You can just point, pointing. You have learned it, right? That's why again you have learned pointing process. Eight methods of pointing you have learned. You can do either one of the pointing process, and you can finish it off. Else, you can go for plastering process. In the plastering process, it is very, very important that before which itself, we do all sorts of electric conduit works. While we go for electric conduit works, you can see that wall dimension is just 3 meters. Wall dimension 3 meters. How much electrical conduits are there in one simple wall? You can see. And that too in the horizontal level itself. All conduits are in horizontal level, which is the curves. Why? Because you all should understand the load transfer of any civil engineering structures is one about the other. That is compressive type of nature. Now, once you have a big gap, a horizontal gap over there, that layer is the weakest layer. Am I correct or not? So there will be more crushing over there, and there is a tendency of forming more and more cracks. So, if you want to do any conduit works, don't go for truly horizontal, go inclined. Okay, surpass through the masonry works with minimum amount of conduits. You can see almost 2 meters fully lost, the integrity is fully lost because of conduits. Again, 1 meter ആകുന്ന രീതിയിൽ ഒരു 3 മീറ്റർ ഇച്ചിരി കഴിഞ്ഞാൽ 1 മീറ്റർ ആകുന്ന രീതി 2 മീറ്റർ വാൾഡ് correct? Yes or no? In the 2 meter you can find a lot of conduits, and all this conduit is going to be vacant place. So that is going to affect the structure because the load transfer will not happen properly. Now, this is a suggestion. Normally, wherever a column is there, you can easily identify the position of the columns because column will behave in a different way, masonry will behave in a different way, and the cracks will form out. So in order to avoid that, make it integral, we recommend something like provide a chicken mesh on either side and then do the plastering. If you do so, that cracks that is being occurring between RCC and the masonry will not be there, and it will not be legible. It will be avoided. That cracks can be avoided. And while you want to make some impressions or if you want to cut any structure, what we normally do is we will hammer and chisel and do more sorts of works. But please to understand, it's a mason structure. It has not attained its strength. So since it has not attained its strength, obviously, it is very, very prone for damage. Am I correct or not? So what we have to do is, there is something known as acting chisels. Special chisels are available. It is not a pointer. Now, all the chisels that you normally have will be of pointer edges, right? A single pointer. Bigger version acting chisel. So we have to avoid that. We have to have a wider chisel. That is known as acting chisel. Using that only you are supposed to cut the structure. Otherwise, the entire integrity of the structure will be lost, and you go for ceiling plastering. Persons, while doing plastering, will include high amount of thickness also. So, n number of figures where the plastering thickness is more than 1 centimeter. Plastering thickness itself is more than 1 centimeter. For example, what I have plastering thickness has no value. Plastering is measured in square meter. Area ആണ് പ്ലാസ്റ്റിക്കിന്റെ വാല്യൂ. അപ്പോൾ എന്ത് വേണം? ഏരിയ മാത്രം നോക്കുള്ളൂ, thickness നോക്കില്ല. So thickness should be reduced. Okay, and when you do the ceiling plastering, obviously they will reduce all thickness because what happens? Our great Newton has found out all those of gravitational pulls, and if you provide high amount of thickness, obviously it is going to fall. So there they will end up very perfect plastic. There is 1:3 proportion they will be. They are very particular about it and they will do plastic. That's science. But the other case, it is ignorant. They will just ignore it. You can see the thickness over here. And many places you will never observe this one. What is this? Planing rock. Planing rock. Never persons will use this. They will have a shorter one. A shorter one. But it should be almost a bigger one. And സാധാരണ കുളത്തിന് സൈസ് പറയുന്നത് ഒരാൾ പിടിച്ച രണ്ട് എഞ്ചിനീയറിംഗ് ആണ് സൈസ് mini tube work. It should be like this. Stretch on either direction, that means length should be your planing rod. And by doing that, we can have a uniform thickness of plastic only. There will not be any bulge. If you have a bulge, you have to spend more on cookies. You know what is a cookie, right? They are also white part is some cookie or diamond. Paint it in. A cookie is in the trash or if you have a bulge. So how can you check whether there is a bulge? Whether there is an irregularity of the structure, irregularity in the plastering. How can you find out? Night time is very easy. Switch on all the lights. Okay. Go with the torch. Place the torch very nearby your wall. Light it. You will find all sorts of undulations. Right out and see. Okay. Go to the walls. Place the torch like this. Light can smash like this, right? This is your wall. Flash it out. You will find all sorts of irregularities in your walls. Easy. Right out. Okay. Will you do it? Right now? Okay. So this is the easy method. We can find the irregularities of plastering. Now, this is all about the planing, verticality, etc. And you can see one of the plastering being done. And you can see it has not even attained the parent structure. What is the parent structure here? There's a parent structure on the other end, right? And it is as good as something like in 10% of you will have 2 pieces, right? Yes, sir. It's just like that you can put many things inside. And if you put 2 rods in between and just put it out, entire layer will come out. And see how much thickness they have done already. How much thickness has been adopted. This has a big story because this is one of our site, which we were the quality inspectors and we discarded this. Okay, it was so horrible. We have found like in one side, he was just a helper, and when he comes to the next side, he is a researcher. So that literally will happen. This type of research will happen, right? So I can help her. After that, you know, so it is quite natural. And curing has to be done properly. Should wet it because that is the only time you are going to fetch water. Later on, otherwise bricks will find its way to get water. You should not do that. And coming to the basics of concrete, I think S5 students are there. They will help me out. And junior students are there. They will just listen to it. We are going to learn this in the next semester. Okay. And the basics of concrete. Concrete is a blend of different materials. Major ingredients are there. All of these stand for right. We like you not sleep, but we sleep. You'll find it's a blend of different materials. Some of the ingredients are very, very important, and some of them are just like family friends. Okay, so I will just relate that with family. It's only situational. It does not have any relevance with anybody's family. Okay, does not have any relevance with anybody's family. I'm just going to relate it. Please listen. Always understand there is two important factors: cement and water. Cement, the elder person of that family, very very important, who guides everything, who determines everything. Second one is water, the elder son of the family. Okay? Second one is the elder son of the family. So these two should be good enough for a good family. Am I correct or not? Elder son and the elder member of the family should be good enough. And our parents allow today, our family are able to do. Am I correct or not? Do you agree with me? Okay. Now comes cement and water is over. Then two things are there, right? Fine aggregate, coarse aggregate. That small chashma wala wale is the fine coarse aggregate. Fine aggregate is, you can see two small fine aggregates, right? Different setups. Am I correct or not? Small kid is fine aggregate, and the other one is that you can imagine like a 10 mm aggregate, and there is a 12 mm aggregate over there, that's chashma wala. Do you agree with me? Yes or no? Yeah. There are other materials which helps the family. You know, our Bobby, your grandma of that family, is fly ash. Okay, you can relate it as a fly ash. Is that okay? And the other person, second son of the family, can also be some material which help him in making that family. Is that okay? It's like DGBS or CW, like that. Now comes, please forgive me, all ladies. Are in the family welcome. Family ki kadanu varuna alan girls. Adha ella incompatibilities nokide avare chemistry anale. Yes or no? That is your chemical admixtures. Chemical admixtures. And just relating, it's not a fun. Chemical admixtures, why I give that role over there is, that is a person who is de-linking many things for many other types. You know, first it will go and attack cement and not allow water to react with cement. Am I correct or not? Yes or no? Okay. It will react with fly ash also. It will react with fly ash also. Am I correct or not? And if the compatibility is not good, your concrete is not going to sustain. I mean, agreeable? Yes or no? And sometimes the second son you can have your additive like fibers and all those things. Is that clear? So this is not intentional, but this is a fact. Concrete is always like a family. It has more or more that related to human beings. Just to make an emphasis of it only, I just said this. In all lectures that we give in the class, we cannot say all this because we don't have much of time. This is a technical talk. I can explore a little bit more. Now, when you make a family, it is as good as making a good dish. Now, for making a good dish, it's very important that each and everything that you do is very, very important. Right? Including the vessel that you select for preparing. You are going to prepare a good sambar and you have a very small vessel. How will you make it? Is it possible? No. Correct or not? So that vessel also is very important. That prime important material, and also the ingredients that is going into it one by one. So for getting a good concrete, we should have good quality raw materials. Its proportion should be good. Say I have more amount of vegetables and less masala. Whether your sambar will be good. Equal proportion should be there. Or required proportions are essential over there. Mixing is very important. You have to blend it properly. Transporting, placing, comparing, curing, and all is all about the process of concrete. Is that okay? Which we will learn in detail in the classes, not here. Now the coarse aggregate, fine aggregate, you can see that determines the quality of the concrete, especially the selection of aggregates. So in the normal sense, In the normal, please understand this is YouTube streamline, so behave properly in the class. Okay? And you will understand like the aggregates, coastal aggregates would be there would be voids in between. For example, you can take something like a glass jar, fill in equally same type of aggregates into it and observe it. You will find each and every pores in between, right? Yes or no? To fill in that pores, you can have a smaller size aggregates. Smaller size aggregates. And the pores still existing will be refined by fine aggregate, and in between that you will be having your cement and water slurry. So this is the basic phenomenon of any what? Concrete mixture. And this should be in a particular proportion. If your aggregates are more and slurry is less, bonding more. And slurry is more, aggregates is less, again bonding is more. So I'm also clear. As good as your vegetables is not there, masala is there much. And in other case, vegetables are more, masala is less. Same is the scenario. You are not going to get a very good mark. Okay. Now, the arrangements is very important, as if you don't have proper material selected, you will be having voids in between. To illustrate this, you can see like in a vegetable shop how the persons are stacking the vegetables, right? If you take the very mini cucumber also, it is not going to fall down. Am I correct or not? Then after that is not the extra idea homogeneous sliding another cucumbers are ready. Am I correct? Do you agree with me? Yes or no? But if you just stack it just like that, if you take the very bottom, first of all selecting the very bottom itself is going to be difficult. Second important thing is that if you try to take that, the entire things will go out. So here in this stack, you can easily take your required vegetables from here. Am I correct or not? You need not even take the proper cost from. That is the specialty of the stacking of these fruits, okay, or the vegetables in any supermarkets. Now, I'll just stop in another 2 or 3 minutes because when you go for construction practices, this is the place where you are going to get posted. Okay? Initial stage I am saying. You may feel like it is very, very simple, standing there. You are going to manage why in our graduate attributes. You know what is graduate attributes, right? In the we have something known as POs, that is graduate attributes, in which there are many factors, 12 factors are there. You should be versatile enough how to communicate your things. So this is the place where you are going to communicate. Okay? You have to deal with the labor, you have to deal with the clients, you have to deal with your peer groups, okay? And sometimes even in a different style like your contractors. Because they have a different, they are not technical persons. So it is very important that when you stay at any site, you have to be versatile. You should know in and out of the